Hello, my name is Jenny Pittman, and I am the Science and Operations Officer at WFO Topeka, Kansas. I will be taking you through a module on improved IDSS messaging via detailed mesoanalysis. By the end of this lesson, you should be able to identify our partners and their needs, identify tools and techniques for IDSS messaging, and should be able to list some best practices for IDSS messaging both in the few hours prior to a severe weather event and during a severe weather event. Let's first start by defining our National Weather Service partners. The National Weather Service works with a broad range of partners, including those in national, state, and local government, members of the weather enterprise, Weather Ready Nation ambassadors, and academia, to help people in all communities stay safe and to ensure important weather information, such as warnings, reach the broadest possible audience. In this presentation, we will focus primarily on the partners that a National Weather Service WFO interacts with on a daily basis, and especially during severe weather, which are emergency managers and the broadcast media. Since our partners are varied, the question of what our partners need from us isn't a simple one. Even within the categories of emergency management and broadcast media, needs and capabilities will differ based on the individual partner, their experience level and interest in weather, the size community they serve and the part of the country in which they are located, and many other factors. It is important to determine who your core partners are prior to a severe weather event and find commonalities in their needs so that you can meet them appropriately. In this module, the general needs of WFO partners in areas that experience severe convective weather are considered. So let's first consider our partners in emergency management. In general, they will need as continuous a flow of information as possible, so they can pass that information to local officials and other decision makers whenever asked. They also need to know your certainty and confidence, as it helps them decide whether to act quickly or to wait for more information. Since emergency managers are often passing your information to others, they will need deliverables like graphics, social media posts, and outlooks in plain language. Even if they are capable of understanding more complex information and terminology, those that they share the information with are less likely to comprehend jargon. And finally, emergency managers often have specific decision points and thresholds for action. Some examples of the decisions that need to be made prior to and during severe weather include the activation of emergency operations centers, activation of spotters, and siren activation. As an example, here is the decision matrix included in the Standard Operating Guide for Johnson County, Kansas. In the matrix, you can see which actions are taken based on the triggers on the left. While some of these triggers are straightforward products already provided by all National Weather Service offices, some, like potentially tornadic storms, are not tied to a specific product and require additional information from their local office. The needs of our media partners overlap quite a bit with the needs of our emergency managers, but also include more science. Broadcast meteorologists may not have time to dive into the detailed mesoanalysis and will want you to summarize the relevant information for them so they can decide what to share on air. They also need to know when a forecast has changed significantly and why. You can think of your communication with the broadcast media as a collaborative forecast process, but remember that you likely have more time and perhaps additional resources to create a detailed mesoscale forecast. Additionally, keep in mind that once broadcast meteorologists are on air, they need lots of information to fill the time and keep the public informed. Reports of severe weather and any new information you can give will help them tremendously when they are on camera during severe weather. In this next example, you can see how a severe weather report makes it through the entire integrated warning team, from emergency management to National Weather Service, and then to the media to be shared with the public.
So we're monitoring storms all over the place, but the one that has the most likely tornado, actually now I'm getting confirmation. Emergency management is reporting a tornado on the ground south of Lone Star. This is exactly where we were just focusing on the radar velocity scan. So this is the location right here, guys.
So how do we provide the services our partners require during severe weather? This list of IDSS services provided by the National Weather Service is all-encompassing and includes a mix of products and dissemination methods. Several of these services are provided automatically, like INWS and most of the information on our website, and some should not be provided during severe weather, like training and exercises. Those IDSS services that could feasibly be provided prior to severe weather as a result of detailed mesoanalysis include NWS chat, graphics, webinars, social media posts, and briefing packets or outlooks. In this presentation, we will focus primarily on NWS chat and graphics, as much of the content in social media posts, briefing packets, and webinars may be derived from these graphics. Mesoscale discussions in the AFD, while not mentioned specifically here, are also an option, but will likely be less visible than a mesoscale discussion provided in NWS chat. Now that we've identified our partners and established which methods we can use to support them, let's talk more specifically about how mesoanalysis feeds into good IDSS. In the few hours prior to a severe weather event, the environment will be evolving, a convective watch may or may not be issued, and partners will be looking for information about where and when severe weather may begin. Partners in both emergency management and the media will want information to share, and will want to know what they should keep an eye out for that will key them in that severe weather is imminent. For example, should they be looking for storms to develop out west, or will they develop overhead? Should they be waiting for the sun to come out, or for Q to start developing? These clues and visual keys they can look for, while not always applicable, can help your partner feel more involved and more confident about how the next few hours will play out. Some of the decisions that are being made in this time frame include Emergency Operations Center staffing and activation, event safety procedures, the opening of shelters, staffing for broadcast meteorologists, media coverage, and many others. So let's look at an example, which was a severe weather event on April 8, 2015. When the 13Z Outlook was issued, a broad enhanced risk for severe weather was placed over portions of northern Oklahoma, eastern Kansas, and central Missouri. That outlook was updated at 1630Z to add a moderate risk for portions of Oklahoma, Kansas, and Missouri, including the area just south of the Kansas City metro. Also highlighted with this update was an area with a 15% hatch tornado probability. The 10% hatch tornado probability extended into the Kansas City metro area, while the 15 ended just to its south. We will be focusing primarily on partners in the Kansas City metro area for this example, and some of the services provided by the office in Pleasant Hill. After the outlooks were released at almost noon local time, a partner webinar was held and the waiting game began. Shortly before 2:30 p.m., a mesoscale discussion was sent by the Storm Prediction Center, which highlighted an area where severe weather was possible. The outlook mentioned all hazards, and was outlined in red, which many partners interpret to mean the type of the planned watch as tornado, even if not stated in the text. The watch probability listed in the product was 95%. However, at 2:50 p.m., a severe thunderstorm watch was issued for the area highlighted in blue. The watch was communicated to partners through radio, MWIN, NWS chat, and this tweet, sent at 2:55 p.m. The tweet caused some confusion with the public, seen in these responses. Many were confused at the location of the watch south of Kansas City, and the type, which was severe thunderstorm instead of tornado. The office responded that additional future watches were possible, and the severe threat would expand by the evening. So let's dive into some basic mesoanalysis for this case, valid at 3 p.m. local time, so just after the watch was issued. You can see a gradient of surface-based CAPE across the Kansas City metro area, with pretty high values to the south, as well as an eroding of surface-based SIN near the gradient. 0 to 3 kilometer lapse rates were highest in northern Oklahoma and portions of southern Missouri, and were a bit less impressive near and south of the Kansas City metro area. 0 to 1 kilometer SRH was highest along and north of the gradient in instability, so generally from the Kansas City metro area northward. However, effective SRH is highest farthest to the south, and the effective inflow base from Kansas City northward was elevated, indicating developing storms may not benefit from the enhanced 0 to 1 kilometer shear. Putting these pieces together, it would appear there is a boundary draped across the Kansas City metro area, and mainly elevated storms are expected to the north. And you can see this boundary very well in surface observations, where Kansas City is in the low 70s with a calm wind, temperatures are in the 80s to the south, and are in the 50s to the north with a significant area of fog and stratus. An approximate location of the front is drawn with a red dashed line on this slide, as well as the ongoing warnings and radar reflectivity at 3 p.m. Storms are beginning to develop across southeast Kansas, but are progressing mainly east-northeast and appear unlikely to interact with the boundary anytime soon. So let's pause and reflect on where we are. A severe thunderstorm watch was issued 10 minutes ago, but does not include the Kansas City metro area. Skies are clearing, temperatures are rising, and the convective outlook still indicates a moderate risk with 15% probability of significant tornadoes just to the south. However, storms are well to the southwest. As a partner, what questions would you have? What about as a member of the public? As the mesoscale analyst? These questions, including your own, are important to consider when deciding what to communicate. At this point, a graphic may be the most effective way to communicate, especially as we continue to wait in that gap between the watch issuance and the onset of severe weather. Meteorologist Brian Berg will next take you through a brief lesson on creating effective IDSS graphics and a few examples, including a possible graphic for this April case.
Now we will transition into applying this detailed mesoanalysis in order to aid the IDSS meteorologist with creating graphics. The National Weather Service has great methods for disseminating thunderstorm information in the days and hours preceding a severe weather potential, for example, convective outlooks and watches, and with severe weather imminent through severe thunderstorm warnings. However, there is a tremendous information gap in the 1 to 3 hour time frame before convection develops or progresses into the area. This portion of the module will focus on conveying clear and concise IDSS graphics for various weather setups, again focusing in on the 1 to 3 hour time frame before severe weather. Here are some of the key elements to keep in mind when creating these short-term graphic casts. Utilize the detailed mesoanalysis and apply your interpretation of the mesoscale environment to the anticipated hazards and impacts. Again, focus predominantly on the 1 to 3 hour time frame preceding convection. The spatial scale should focus in on a few counties to even a sub-county level. Keep the graphic simple as meteorological knowledge varies greatly amongst the public and our partners. The user should be able to get the message you're conveying at just a short glance. Keeping the message simple allows for the message to be shared easily. And finally, the graphic does not have to be complicated. Please keep it simple. Now we will take a look at a few examples from past convective events. For these examples, we will utilize this base template with key points being what, where, and action. Sticking with the previously mentioned event across portions of east central Kansas and western Missouri, notice this graphic encompasses several counties from southwest to northeast. The detailed mesoanalysis revealed a favorable convective environment along the frontal boundary. With the graphic disseminated during the pre-initiation time frame, uncertainty is inherently higher and a larger area is justified. Transitioning into example number 2, after conducting detailed mesoanalysis, we find a favorable environment for severe thunderstorms, including a strongly sheared low-level environment that may support tornadoes. The strongest surface convergence is very near the triple point in central Kansas and is likely the area where initial updrafts may develop. A tornado watch was issued at 3:45 p.m., but convection is not expected for a few hours. What might a short-term graphic cast look like for this event? This graphic focuses in on the triple point area for convective development between 5 p.m. and 7 p.m. Additional short-term graphics will likely be needed for other areas, but again, this graphic focuses in on the initial zone for convective development. Now for the third and final example, we will look at a broken line of thunderstorms currently west of the forecast area. After conducting detailed mesoanalysis, we determined that the ongoing thunderstorm activity is likely to continue into the forecast area. Utilizing the time of arrival tool, the current projection is that thunderstorm activity will move into the area within 2 hours. Low-level shear is progged to rapidly increase near sunset as the low-level jet increases, potentially increasing the tornado threat. How can we construct a short-term graphic cast in this scenario? Again, we created a very simple graphic highlighting the western counties of the forecast area. Since the storms are ongoing west of our area, the verbiage used in the graphic states that storms are expected to move into the yellow shaded area rather than develop in the area like we used in previous examples. The detailed mesoanalysis reveals the potential for strong tornadoes. As such, the text was modified to express that threat. Bottom line, Keep the graphics simple, but leverage the detailed mesoanalysis to highlight the area and threats within that area.
Before moving on to the next topic, let's briefly return to our April 2015 case. Brian mentioned the uncertainty in the location of severe weather over the next few hours, and why that resulted in a larger area being highlighted in our IDSS graphic. However, even that area was too small to communicate another important message, which is that additional severe weather is still expected later in the evening. A graphic like this could also be communicated to partners and the public around a similar time to head off questions about Kansas City and whether the risk had shifted south for the entire event. Another great way to communicate with our partners is through NWS chat. The users in chat are generally our core partners: emergency managers, safety and emergency personnel like fire and police, electronic media including print, television, and radio, government officials at local, state, and federal levels, and Skywarn net control operators. Training and approval from the local office are required for users to join, but meteorological knowledge of the users still varies widely. Posts in NWS chat are a mix of automation from the NWS bot and manual entries from users. While automated posts for things like watches, warnings, and mesoscale discussions are important for immediate dissemination and notification, it's also important to keep chat a two-way conversation and not let the bot do all of the posting. This is your chance to add more detailed information than you would put in a graphic, and to give a little more meteorological background and reasoning. While a more scientific discussion may not appeal to all users, it can help give partners confidence that you are knowledgeable and informed, and it is unlikely that partners will be copying and pasting out of chat, so not every word needs to be in the plain, concise language you would use in a graphic. Just be aware that some users may ask you to translate the meteorological terminology, so you will also need to explain what those terms and values mean and what the implications are on severe weather potential. So using our April 2015 case, let's consider the needs of Johnson County, Kansas, whose SOG was shown earlier in the presentation. They are a large county in the Kansas City metro area with a population of around 600,000. Their EOC has been activated to level 2 since 6 a.m. due to storms that moved through the area earlier, and the outlook for the afternoon and evening. They are required to remain activated, but are waiting to send out spotters. The severe thunderstorm watch that was issued at 3 p.m. does not include their county, but borders them to the south, and they need information to share with their county manager, their city officials, schools, and others. What would you tell them in NWS chat? Here is an example of a question that might be posed by the county EM, and a possible response. You may pause the video if you would like to read the entire response, but it focuses mainly on an explanation of the current round of storms, timing for the next round, and a key to look for to let the county know that storms are imminent. Now, using the same case, let's consider the needs of the local Kansas City Fox affiliate, Fox 4KC. They cover a large area, including eastern Kansas and western Missouri, and have begun staffing up and adding extra weather segments into their broadcast. They are not doing wall-to-wall coverage yet, since there are no active warnings in their coverage area, but the Severe Thunderstorm Watch does cover the southern tier of their area. Their primary needs right now are information to share on their additional weather segments, on social media, and in their weather blog. What can you tell them in NWS chat? Here is an example of a question that might be posed by the broadcast meteorologist and a possible response. You may pause the video if you would like to read the entire response, but it focuses on a broader area, discusses the position of the current and anticipated storms relative to the warm front, and highlights the expected hazards. Finally, you could head off both of these questions with a mesoscale update in chat. You may pause the video if you would like to read the entire response, but in general, this post uses a little more meteorological information while still explaining how that impacts severe weather threat and timing. During an event, the IDSS you provide will be a little bit different. The environment is still evolving, warnings are in effect, but it's important to note that there are still portions of your area that are still in the waiting game, and detailed mesoanalysis is still important. Many partners may try to extrapolate current warnings, but don't have the tools and environmental knowledge to do so accurately. Additionally, partners still need information to share, and will still need to make decisions about things like event safety, media coverage, and siren activation. In this example, we will focus on the 24th of May in 2019, still in the Kansas City area. A broad slight risk is present through the southern and central plains on the 20Z outlook from the Storm Prediction Center, and includes a large area of 5% tornado probability. A tornado watch is in effect to the southwest of Kansas City by mid-afternoon, and a few hours later, a mesoscale discussion is issued for the areas to the northeast of the watch, including the Kansas City metro. In the next loop, you will see visible satellite imagery from 9 a.m. to 12:30 p.m. earlier that day, highlighting cloud cover early in the day, an eventual partial clearing, and more robust storms developing to the southwest by early afternoon. So let's look at some basic mesoanalysis for this case, beginning at 4 p.m. local time, just after the mesoscale discussion was issued. A gradient and surface-based cape is located across the Kansas City metro area, and the warm sector is generally uncapped for surface-based parcels, except perhaps just north of the metro. Effective SRH is between 1 and 200, and the effective inflow base is 0, indicating that storms are expected to be surface-based. 0 to 1 kilometer SRH is highest to the southwest at this time, and appears to be greatest along the gradient and cape, maxing out at around 150 meters squared per second squared in east central Kansas. And in this same area, the significant tornado parameter maximizes around 2 to 3 for an effective layer, a bit to the southwest of the Kansas City metro area. It's now 5 p.m. local time, and storms are still in Topeka and Wichita's area, but they are fast approaching. You are also watching some storms up north of the metro area, so it's safe to say that severe weather operations are underway. The tornado warning southwest of the Kansas City metro area would likely cause metro area and eastern Kansas counties EOCs to activate, but they will be extrapolating current warnings and storm motions. What about the storms to the south that don't have warnings on them yet? Do you think your partners are watching them? Should they be? While all of these are examples of possible IDSS services, the best and most visible service you can provide at this time is a discussion in chat. During severe weather, you may be too busy to create graphics, and partners may not see them in time. By 6 p.m., a tornado watch is issued for the Kansas City metro area and areas to the east that were highlighted in the mesoscale discussion several hours earlier. A look at the radar shows storms continuing to approach, but the tornadic storms have turned due east, and their polygons show them headed mainly south of the metro. The storms that were in your far southwestern CWA have lifted straight north and have begun to merge with the approaching convection, meaning a linear extrapolation of current storm motion may not be the best. It's important to remember your partners will be trying to plan where these storms will go next, and it would help them quite a bit if you communicate how you expect storms to evolve over the next few hours. Here's an example of a question that might be posed by a broadcast meteorologist and your current analysis. You have noted that the boundary or gradient instability has been lifting north, but is still a county south of the Kansas City metro as storms are moving in. Storm mode is messy due to mergers, but low level and 0 to 3 kilometer shear are both enhanced near and just south of the boundary. LCLs are low, and low level lapse rates are high. Your emergency management partners have activated their EOCs and are considering sending out spotters. They can see Topeka's warnings, but they are having trouble extrapolating. You have this question from Carly in chat, and know that your EM partners have questions as well. What information would you want to share in NWS chat? The only thing you won't want to highlight here is that the northern metro doesn't have a threat for tornadoes. It may be lower than the southern metro, but you don't want to rule it out with a favorable environment and confusing storm modes. Although we haven't talked enough about the environment to truly determine the flash flood threat, the training storms and messy storm mode certainly make flash flooding a possibility. Now that we've worked through our objectives and examples, please take a moment to review this summary and key points from the lesson. While we serve a broad range of partners and customers, our primary customers at the WFO level are emergency managers and the media. There are many IDSS and dissemination methods available, but graphics and NWS chat are the primary methods to use in the 0 to 3 hours prior to severe weather. Partners will be asked by the public and other decision makers for frequent updates, so they will need as continuous a flow of information as possible, and proactive chats and graphics will be appreciated. Use meteorology and explain it. This is your chance to assert your position as the scientific head of the integrated warning team. And finally, detailed mesoanalysis is key to helping partners plan and respond efficiently. Thank you for your attention and for completing this module.